subtracting fractions and decimals. So we may get a fraction and they want us to subtract. So let's say 8/10, and I'm going to subtract 2/10. The first thing we look at is our denominator. Are they the same? Do we have a common? Yes. So because our denominator is the same, I just bring that down. That's going to stay the same, because remember that's total in each. And then my numerators, I just subtract. 8 minus 2 is 6. So 6/10, and then I look at, can I reduce? Well, yes, I could divide both by 2 and get 3/5. Okay, so that's a simple subtraction problem with our denominators nice and common, and they're the same, and the top number is bigger. So what if we had one that we did not have the same denominators? So let's say we had 7/10, and we're going to subtract 3/5. Well, just like we talked about with the adding fractions, first thing I have to look at is our denominator. We need to find a common denominator. These are not the same. So I'm looking at 5, and I want to know what multiple of 5 10 will also go into. Well, I know that 5 and 10, the LCM, or the least common multiple, the first multiple that they both have in common would be 10. So I know my denominator is going to be 10, so that they now match. Now I need to look at 10, 7/10. Well, how do I get from 10 to 10? Well, I didn't do anything, so all I have to do is bring over my 7. But on the bottom, I need to think, how do I get from 5 to 10? Well, I know that's times 2. Whatever I do to the bottom, I do to the top. So 3 times 2 is 6. Then I could subtract. Remember, our denominator stays the same because it's the total in each. 7 minus 6 is 1. So my answer would be 1/10, and that is reduced all the way down. Okay, so what if we have a mixed number? Let's start off with 1 and 7/10. And then we have, let's just use the same one, 3/5. You're going to use the same step. First, I look at my denominator. It's not the same. So I need to change it so that it is. And we know from the last one that we just did that our denominator is 10. This one stayed the same. For here, it was times 2. So it was 6/10, but I've got to bring my 1 over because that was my whole number. So 7 minus 6 is 1. Denominator stays the same. 1 minus nothing, because there's no whole number there, I just bring my 1 down. That'd be 1 and 1/10. So with our whole numbers, just treat them as whole numbers. Just make sure you don't forget them. A different situation might be where we have, let's do 1 and, or let's do 7 and 1/2. And then 3 and 3/4, and we're subtracting them. Okay, so the first thing I see is this is not a common denominator, so I have to think 2 and 4. I know that the LCM would be 4. I know both of these denominators will be 4 because both go into it evenly. On the top, how do I get from 2 to 4? I multiply by 2. Whatever I do to the bottom, I do to the top. On the bottom, I don't need to do anything because it was already a 4, so I'm just going to bring that 3 over. But then I need to bring over my whole numbers and just rewrite it. So what I notice at this point is 2 is my numerator here. 3 is my numerator on the bottom. Well, we know from regular subtraction rules, 2 minus 3, we can't do. So we have 2 different options here that we can work with. First, we could change this to improper fractions. So remember, that's our Texas strategy. And I know that 4 times 7 is 28 plus 2, and that's going to be over 4. It does not change. 4 times 7, 28, 29, 30. Make that improper. Do the same here. fraction, so that's basically 4 times 3 plus 3, save over 4. 4 times 3 is 12, plus 3 is 15 over 4. Now can I subtract them? Well, yes, now I can, because now I have 30 minus 15, which is 15. Denominator stays the same. Now I have an improper answer, and so I'm going to bring it back out and make it mixed. Remember, this is top dog. So he goes in his house, divide it out. Three and 3/4. Backwards check, just make sure, go back and make sure it still matches. 4 times 3 is 12, plus 3 is 15. 4 these, check. So I could do improper and then get back to mixed. The other thing that I could do is just make them fractions. So let's go back to 7 and 1/2. So here was our original problem, 7 1/2. And we were trying to subtract 3 and 3/4. Well, I know my fractions, I'm sorry, not fractions, decimals. Decimals, 7 1/2, and a decimal would be, well, I know my half is a 0.5, so I just put my whole number in front of. I know 3/4 is 0.75, so those are my benchmarks, and I just put the 3 in front of. I'm going to add a 0 just to make sure that both are the same place value, and then subtract as normal. The nice thing about subtracting decimals is it's the same as whole numbers, we just have to remember that decimal's there. So 0 minus 5 I can't do, so I can borrow. 10 minus 5 is 5. 4 minus 7 I can't do, I have to borrow. 14 minus 7 is 7. 6 minus 3 is 3. So 3.75, which 3 and 3/4 here matches. So you could do either one to subtract fractions when the top number, the numerator, is smaller than the bottom number. So when this is smaller than this one, we can do either improper or we can do decimals. Either way would work. Okay, so let's have you try one of those. Let's do let's do 1 and 3/5, and let's subtract 7/10. Okay, so pause the video, try this one on your own, and try the improper and try the decimal to see which one you like, and then come back and check it with me. Okay, so you should have done this on your own. First thing you should have looked at is my denominator is not the same. I know that between those two, my denominator is going to be a 10. 5 times 2 is 10, so 3 times 2 is 6. 10 is already there, so I just have to bring it over, but I'm going to bring over my whole number as well. I noticed that my 6 and 7, that's not going to work, 6 minus 7. So let's do improper. With our Texas strategy. So Texas lasso, so 10 times 1 is 10 plus 6 is 16. Denominator stays the same. Texas lasso, but there's nothing there. So this would be 10 times nothing there plus 7. Well, really, we just leave that as 7/10. We can't make it improper because an improper means that there's a hole rolled into it. So we can just subtract these as they are. 16 minus 7 is 9. Denominator stays the same. Can I reduce? No. Okay, the other way I could do it is decimals. I'm going to write this one correctly this time. Decimals. So 1 and 3/5 is the same as 1 6/10, because we don't have a fifths place. 7/10 would just be 7/10. I could add a 0 here if I wanted to subtract, borrow, and I end up with 9/10, and these two match. Okay, let's try one more on your own. Let's do 4, and let's do 1/8, and let's subtract 3 3/4. We're going to subtract those. So go ahead and pause the video, try it on your own, and then come back and check with me. Okay, so first thing I look at is no common denominator. I need to make a common denominator. 8 and 4, I know that the least common multiple of both would be 8. So on the top, I don't need to do anything because it's already there, but I am going to bring over my whole number. 4 is times 2, which means I have to do it to the top and bring over my whole number. Now they match, so now I can subtract, but I look and I have 1 minus 6. Well, that's not going to work. We can't take 6 away from 1. So let's do our improper. Texas lasso. 8 times 4 is 32, plus 1 is 33. And the denominator stays the same. Texas lasso. 8 times 3 is 24, plus 6 is 30. Denominator stays the same. Now I can subtract because my bigger number is on top. 33 minus 3 is 3. Denominator stays the same, so 3/8. Now with a decimal, let's go back to the beginning. We had 4 1/8, 3 3/4. Okay, so we have 4 1/8. Well, we know 1/8 is 0.125, because that's a benchmark, and we're going to put the 4 in front. For 3/4, we know that that's 0.75, so that's a benchmark, and then put the whole in front. I'm going to add a 0 just so they're both sitting with the same place value, and then subtract. 5 minus 0 is 5. 2 minus 5 can't do, so I'm going to borrow. 12 minus 5 is 7. 0 minus 7 I can't do. Borrow. 10 minus 7 is 3. Bring down my decimal. 3 minus 3, 0. So my answer is 0.375, which matches 3/8.